Hello and welcome. In the last video, we discussed how LinkedIn engineers solved the multiple live video problem, and they introduced the subscription model where the client subscribes to different videos and the manager actually handles all the process. Now engineers are faced with a new problem, and that problem is 10,000 concurrent viewers. Now we have 10,000 viewers, and this delivery system, this real-time delivery system, is definitely not capable of handling these numbers of concurrent connections. So what is the solution? So this is the scalability problem. Now the system is scaling, and we have to accommodate this scaling issue. This is the new solution designed by the LinkedIn engineers. It's a very simple and understandable solution. Let's try to understand this. So this is our real-time delivery system, and this is also a real-time delivery system. Let's call this node 1, and let's call this node 2. So now we have multiple machines. So now we have two real-time delivery systems machine. One is the node 1 and second is node 2. So one set of client is handled by node 1, and another set of clients are handled by node 2. And in the same way, we have the dispatcher. This is the real-time dispatcher. So this real-time dispatcher is the one who will handle these nodes, these multiple nodes. These can be more nodes here. I have just drawn two nodes. So this real-time dispatcher will handle the different machines, and then these machines will handle different clients or different users. So how this works actually? So these machines, the real-time nodes, the real-time delivery system will subscribe to the real-time dispatcher. So we have a dispatcher manager. So we have something like this: topic and node. For example, we have, so node 1 is handling live video 1 and live video 2 and live video 3. So, and likewise the node 2 is handling live video 1 and live video 4. So we have this case, one node is actually managing three videos, live video 1, 2 and 3, and node 2 is handling live video 1 and 2. So in the real-time dispatcher, the dispatcher will register the nodes. For example, node 1 and live video 1, node 1 live video 2, and node 1 live video 3. And likewise, we have node 2 live video 1 and node 2 live video 4. So we have all these entries, we have all the nodes and the number of live videos they are handling. So now we have likes, and these likes are for the live video 1. So we have our backend system, and backend system is actually this backend system is connected with the manager, and we have these two likes. So the backend system will deliver these two likes to the manager, and then manager will see where to route these two likes. So we have the live video here. One is this one, node 1, and second is node 2. So according to the table information, this will go to the node 1, and this will go to the node 2. Now nodes forward these likes to the users according to their tables, which managed by the delivery manager. So this is how engineer managed to scale their solution, in which they have nodes then subscribes to the dispatch manager, and then dispatch manager delivers the likes to all the nodes who have subscribed to the manager. And this is scalable. As you can see, we can add more nodes, and those nodes will just have to subscribe to the dispatch manager. So we have this design where we can handle 10,000 concurrent viewers with the dispatcher and subscription model. And if you look at closely, the LinkedIn engineers find an issue with this model. So what is that issue? Let's discuss that. So we have this model where we have nodes, and these nodes are connected with the dispatcher, right? So, and dispatcher is managing a table where we have nodes and live videos. Now, what if this dispatcher goes down? Then all the subscription data will also be lost, right? The whole design will fail because now there is no dispatcher, so no likes can be transferred to the live videos. So this means we have a single point of failure at this point. How we can handle this? We can scale this again. How we can solve this problem? Let's see. So as you can see, we have added two dispatcher nodes or two dispatcher instances, and these dispatcher instances will handle different nodes which we have here. So node 1, node 2 is connected to this one, node 3 is here also, and node 3 is connected to dispatcher 2, and node 4 and node 5. Please note that the nodes and dispatcher, they are independent of each other. So this means that a node can be connected to both the dispatchers, right? And dispatchers can have multiple connection of the nodes. The nodes are independent of dispatcher, and the dispatcher is independent of the node. Now there is another problem. For example, if we have a table within the dispatcher, and if this dispatcher goes down, all this information will be lost. So this is important that we should have the tables, the subscription table should not be within the dispatcher, but it should be outside the dispatcher. So we have a dispatcher table outside, and we do not need this dispatcher table here, and both the dispatcher have the access to this. So this is an in-memory data store. So memory data store, and this is accessible to both the instances. So if we have another dispatcher instance here, so that instance can also access the in-memory data store. Now look at this case. If we have this dispatcher down, even though this dispatcher 2, so this dispatcher can handle the likes, and it can receive the data, it can fetch the data from the in-memory store and can service the client. So in this way, this is a scalable solution, and also objects are not dependent on each other. So this looks like a good scalable solution. And now let's see, are we able to handle 1 million likes per second? So for example, if we have 100 likes per second, and we saw that we can handle 10,000 concurrent connections. So if we have 10,000 concurrent connections and we have 100 likes per second, so if we multiply 100 by 10,000, so we will get the value, which is 1 million, right? So with this structure, we are able to handle 1 million likes per second. Now let's summarize this whole system design and see how different objects of this system interact with each other, and how LinkedIn engineers achieved 1 million likes per second. So the design, I think the design is very, very simple, but yet very powerful. So let's see what we have. So we have a front end, or you can say a node, a real-time delivery system. So this is real-time delivery system. You can also call it's a node. And we have a real-time dispatcher system, and we have a key value store. And we have a backend system which actually gives us the likes or the comments. So what happens is, the subscribers, the viewer, subscribe to the real-time delivery system. They subscribe, and then the real-time delivery system subscribes to the real-time dispatcher. So they subscribe with the dispatcher, and then the dispatcher handles all the information and registers all the information in the key value store. So what happens when a viewer clicks a like on his cell phone or on the web? So this like is actually transferred to the backend, right? So this viewer sends this like to the backend, and then this backend transfers this to the real-time dispatcher. So this like arrives at the real-time dispatcher. Now this like has the information of the video. For example, this has the video ID. So now the real-time dispatcher makes a search in a key value, and it looks for the nodes, right? And it looks for the delivery nodes. So this one looks for the delivery nodes, that on which delivery node that video is being watched, and then this like is sent to the to those delivery nodes. We can have multiple delivery nodes here. As in the same way, we can have multiple dispatcher nodes. And then when it arrives to the delivery nodes, then delivery node will look into their own data store, and will see that which devices are connected and which devices are watching that specific video. And then this like is transferred to all those mobile phones or all those users who are watching that specific video. And again, let's again touch. So we have 100 likes multiplied by 10,000 concurrent users, and this is equal to 1 million likes per second. So this is it, and I hope you would have learned something from this design. I tried to cover all the important aspects of this software design, and I feel that this is very intelligently done, and I hope that we all would have learned something from this, and with this learning we can design our application more robust, scalable, and secure. So thank you for watching.